start. We started to talk about TLS, Transport Layer Security Protocol. So we talked about, we covered in details the three session level protocols, including the change cipher spec protocol, the alert protocol, and the heartbeat protocol. So we discussed all these three. Today, inshallah, we'll focus on the most complicated one, which is the handshake protocol. And the handshake protocol is used to facilitate the user authentication and key exchange between the client and the server. Okay, so that's what we need about today. So of course, these are the types of messages. We'll talk about the time sequence of messages. Again, to take a high-level perspective, we see that we have four phases, although this fourth phase is not actually part of the handshake. It's, as you can see, change cipher spec. So this belongs to the change cipher spec protocol, not to the handshake protocol. So this fourth phase is separate. The first three phases, okay, again, to facilitate the user authentication and key exchange. So in the first phase, at a high level, the client and the server, they exchange the capabilities. They exchange the capabilities, including what type of algorithms or mechanisms are available for every single pillar of security, including authentication, key exchange, compression, if there's any, okay, and integrity, of course, whether we're using which type of MAC, SHA, things like that. So in the first phase, they establish the security capabilities, not authentication yet, and not key exchange yet. In the second phase, the way it's done is that the server will conduct its own certificate exchange, which means authentication. So the server will first authenticate itself to the client and will send the initial parameters for the key exchange, whether we're talking about Diffie-Hellman. So when we talk about Diffie-Hellman, what kind of parameters we need to exchange, Fakrin?
Diffie-Hellman?
Yeah.
The
Y, alpha, and Q, right?
Yes.
Y, alpha, and Q. Remember, we have Y equals alpha to the power X, okay, mod Q, right? And alpha should be a primitive root of Q, okay? So we need to exchange Y, alpha, and Q, right? For other like RSA, for example, we need to exchange what? E and N, right? Things like that, okay? So RSA can be used for key exchange as well, right? Anyway, so in this phase, the server will have to authenticate itself to the client and send the initial parameters to facilitate the key exchange. In phase 3, the client will do the same from its side. Okay? So that's in a nutshell. So we'll go through the messages one by one. So basically, in this first phase, they exchange the capabilities. So as you know, in any client-server communication, who initiates the communication? Always the client, right? Always the client is the initiator of the communication. So the client is sending a hello message to the server to request from the server to start establishing security capabilities, right? And as part of this, it sends also what we call initial random sequence. If you remember last time, we talked about one of the parameters is initial random sequence, and we'll talk about the purpose of this in a minute. Okay, so the client will send a random sequence, which is like the nonce or something like this. So the client sends a hello message to start establishing the security capabilities, and as part of that, it sends the initial sequence number. Okay, and this message will contain the list of preference of all the mechanisms that the client can support for each of the four pillars that we talked about. So for example, for authentication, well, I prefer to use certificates, something like that, okay? But if you don't have certificates, we can use like user ID and password, things like this, okay? For key exchange, the client will say the first preference is RSA. The second preference is Diffie-Hellman, things like that. Okay? So it sends the capabilities in the order of preference. Okay? The server will then say or send back saying, okay, so I have support for this mechanism. I can select your first preference for key exchange, things like this. So the server sends its own response saying that, okay, so for key exchange, we'll use Diffie-Hellman, for authentication with certificates, and so on. Okay? So here, they have an agreement what method is to be used. Like, for example, for compression, we use no compression, or we need to use compression, things like that. Okay? So at this point, they have complete agreement of all the 4 pillars, okay, and what mechanism to be used for each of these. So even though the client is the initiator of the communication, however, the server is the driver of the process in terms of authentication and key exchange. So the server always is the one that drives the authentication process. Okay? And we'll see this again repeats in SSH in a later stage. So the server sends the certificate to authenticate itself to the client, and then it sends a server key exchange, which contains the initial parameters for key exchange. So if Diffie-Hellman, it sends Y, alpha, and Q. If it's RSA, it sends E and N, and so on. Okay? Because the server is the driver of the authentication process, it sends a request to the server to authenticate itself. And then it sends done. So now the server sent all its information to authenticate itself and to facilitate the key exchange. Okay? But the client needs to do the same. So the client will send back. This could be, it doesn't have to be certificate, by the way. The client can authenticate itself back to the server in different ways. And that's why if you pay attention to this, sometimes when you click on a link on a web page, sometimes you see a wording saying, do you want to exchange your certificate with the server? Okay, so that talks about this method. But we could also have a pop-up message that says, oh, okay, enter your user ID and password. That's another way of the client authenticating itself back to the server, right? So here there could be different methods, and we see the implication of this in a later stage. And again, the client will send back, of course, the Y and the parameters for the key exchange, okay? And it sends the verification and done. This verification, it says that to the server that I was able to authenticate you, and my process in terms of authentication is done. Okay? So at this stage, we have the random sequence. Remember, we have the random sequence from both sides. We have the random sequence. And we have what we call pre-master key, which is the shared key as a result of the key exchange process. صح كده? So this pre-master key is normal. So the added value or the added thing here is the random sequence, which is exchanged from both sides, which is the nonce. And we'll see the reason for this. Okay? Based on that, locally at the client and at the server, they can use the pre-master key, as we will see, and from the pre-master key and the random sequence, we generate the master key. Okay? And we'll see why we do this. And then after generating the master key, we generate all the set of keys, which is the 6 keys we talked about in the previous lecture, including the server write key, the client write key for encryption, for integrity, and so on. Okay, and the IV, initial vectors, right? We have all these 6 keys, and we use key expansion technique to generate all these keys from the master key. Okay, but first we have to generate the master key from the pre-master key and the random sequence. once we generate, so now we have a complete data structure that contains all these keys, okay? Which is the complete cipher spec, which is the complete cipher spec, okay? Then we have this cipher spec, so what we need to do is that we send a cipher spec, change cipher spec, to make this cipher spec the current one that we will be used later on in all the connections, all the upcoming tunnels and connections, they will have to use this security parameters. ماشي كده؟ So that these are the four phases for the handshake protocol. Any questions so far? So the creation of the pre-master key, why do we need to create a master key from the pre-master key? I think we talked about this for IPsec and other protocols. Whenever we have multiple ways of authentication, the result might have a different variable length for the pre-master key. So the pre-master key length depends heavily on the method of authentication, right? But the master key needs to be unified and fixed length, right? So from the pre-master key, we have to generate a master key which is of fixed length, 48 bytes, okay? So this happens through the fact that the master key will be generated based on a pseudo-random function of the pre-master key and the random sequence. And other things, and other parameters as well, right? So this is the first step. We generate a master which is of fixed length, and we can do that easily, of course, using hashing, right? And then we can use that master key to generate all the cipher spec parameters in terms of all the 6 keys we talked about for the client and for the server. For the client, there are 3 things: client write encryption key, client MAC key, and the IV. And from the server, the same thing. Okay? So, as we said before, the heartbeat is a periodic signal generated by the hardware. And as we said before, why do we need the heartbeat? We talked about this last time, if you remember, that sometimes if you are doing some purchase on a website and then you stay idle for a long period of time, even though you say that the session is still alive, but the firewall sometimes might block this session and declare that this session is not alive anymore. So to avoid this, inside the tunnel, you have to keep sending some heartbeat messages to declare that this session is still alive, so that when the firewall receives this message, it keeps the session context alive for a certain period of time, of course. Of course, you cannot leave it for a long time, so we have to set some timeout, after which we have to declare that this session is not alive anymore. So this heartbeat will assure the sender that the recipient is still alive, which is the normal heartbeat, and it generates activity across the connection during idle periods, which avoids closure from the firewall, right? So we have to send this periodically for a certain period of time at least. Sometimes, of course, you keep the session open for a very, very long time, in which case, we stop sending the heartbeat messages, in which case the session will indeed be closed. So these are there's nothing new here. There are certain types of attacks that happen in TLS. Remember, in TLS, we're talking about a client and a server. Unlike IPsec, okay? I'm trying to refresh your memories because you've been away for a certain period of time. So for IPsec, we're talking about host-to-host or network-to-network. Here, we're talking about client-server. So, and always the attacks does not reflect any flaws or any problem in the mechanism, okay? But it actually tries to use some loopholes and tries to use some issues related to the protocol design itself. Okay, so most of the attacks, they happen on the protocol, and that's why really security protocols are really key in terms of designing these protocols to make it attack proof. Okay, and there is nothing attack proof, but yeah, you should do it carefully. Yeah. Okay. So attacks that happen on handshake protocol, like for example, we will see like truncation attacks. We try to block some of these messages from going to the other side to kind of block the communication from happening, things like that. Attacks on the record and application data protocol. Remember, the record protocol is the protocol that's used as part of the tunnel. So for this, you can do some kind of crypto analysis to try to guess the key and stuff like that. Attacks on the key exchange. For example, we can use some issue related. Remember, Diffie-Hellman itself does not provide any kind of authentication. So you have to do authentication outside of Diffie-Hellman. Okay, so a key exchange itself has to consider authentication between the client and the server, and we do that as part of TLS. However, some attacks can use the key exchange messages to kind of perform impersonation attack or man-in-the-middle attack or things like that. Okay? There's nothing new here, but the key message is that the attack does not really reflect any flaws in the mechanism, but it actually tries to use mainly the protocol messages. Also, nothing new here. So, of course, here we're talking about SSL. SSL is separate from TLS. And as we said, the TLS version 1 was designed mainly to replace SSL. However, that didn't happen. And that's why in TLS version 2, they tried to make it a backward compatible in order to encourage people to still use it. SSL is triggered when we say HTTPS. So whenever we say HTTPS, we trigger the use of SSL, okay? Which is, again, it works in the same level like TLS. There is lots of similarities and overlap between SSL and TLS, okay? If you say HTTPS, then by default, the browser will use a port 443 instead of a port 80, right? So this is for security, and that's documented in this RFC. When HTTPS is used, the following elements of the communication are encrypted. So anything that's sent, as we said before, anything that's sent through the tunnel will be encrypted. The only thing that's not encrypted is what? Is the TCP header. Okay? Because TLS works on top of TCP. Okay? So TCP header is not to be encrypted. But anything above TCP will all be encrypted. Everything. Okay? So the URL itself is application level, encrypted. The content of the document, of course, regardless of whatever type of this content, is going to be encrypted. Everything is going to be encrypted. And of course, the HTTP header itself, HTTP, in the header, you have to specify the command, whether get or put, or all of this is going to be encrypted. Okay? So everything is going to be encrypted. The only thing that's not encrypted is TCP header. So for HTTPS, the agent acting as the HTTP client also acts as the TLS client. That's normal. There's nothing magical here. So the client initiates the connection to the server on the appropriate. So always the client is the initiator of the connection. But as we said, when it comes to security, always the server is the driver of the security initiation. Okay? Is the one that drives what method the client will use to authenticate itself. And before it does that, it has to authenticate itself first to the client. So that always happens first. Okay? There are 3 levels of awareness of the connection. At the HTTP level, an HTTP client requests a connection. So here we have the HTTP session. Okay? The the HTTP session triggers TLS. If you say HTTPS, it triggers the use of TLS or SSL, okay? And SSL works on top of TCP. So that's what this tries to say. So these are the three levels. So first, HTTP triggers TLS or SSL, and then SSL will initiate the security session. We talked about that last time. And then this works on top of TCP. And that's why TCP itself, the TCP header itself, is not to be encrypted. But everything above TLS is encrypted, including all the HTTP content. ماشي? Yeah, there is one issue here, which represents one type of attack that commonly happens on TLS. One issue that I'm not sure if they have, I think they have fixed that in the new version of TLS, because in the standard of TLS, there was no specification how the security session closure happens. As we have discussed, if you remember, as we have discussed in TCP in network 1 حتى, we discussed this issue. And in advanced networks, we discuss it in more details. So we have the client and the server, okay? And when it comes to establishing the connection, and here we're talking about the TCP connection, not even حتى security tunnel. So the security, when we establish the TCP connection, what happens is that we initiate a connection which facilitates bidirectional communication through the sockets, right? So TCP as a protocol allows the client to send a message called FIN, right? We studied that in network 1, right? This message FIN will close the connection, okay? And this happens abruptly. So the client sending the FIN message, meaning that the socket at the client, okay, will have to be terminated. Okay, the receiver socket at the client will have to be exterminated. Okay, but the closure of the connection from both sides happen independently and asynchronously. بمعنى, the client may send the FIN message, but the server still has some information to send to the client. Okay? If the server has some information to send to the client, the server will maintain the connection in one direction and will still send some messages. So that's what TCP has. When it comes to security, that's an issue. Why? Why? Because remember, here we're talking about this connection is inside a tunnel, right? So inside the tunnel, when you terminate the TCP connection, you will also have to terminate the session, the security session. Okay, so you have to send a close message, okay, to the server to terminate the session, the security session, which means all the cipher spec, all the security context will have to be exterminated as well. Okay, not just the socket. All the security context has to be terminated. Okay, so what is the problem here? The problem is that the TLS standard, okay, maybe taking into consideration the fact that the closure of the TCP connection does not use reliable way of making sure that both sides close at the same time. And there was a reason for this. Okay? But for security reasons, this reliability of the closure is actually important. And why is this? Because if the client sends a connection close, okay, and which means that all the security, not the other socket, all the security context, the cipher specs and everything, is closed. Okay? The problem here is that this message might be blocked by an attacker here. We call this truncation attack. the connection closure does not go to the server. Okay? But the client exterminates the security context and disappears from the end, from this whole picture, right? Gets out. So the attacker might truncate this message, block it from being sent to the server, okay? And then, in a later stage, perform a impersonation attack, okay? And that's possible, why? Because the client is out. The client is now out, so the attacker might actually block this message and start communicating to the server. Okay? It would be nice that the extermination of the security context on both sides happens simultaneously. Okay? And that has to be in a reliable way. بمعنى, when I send you a close, that doesn't mean that this security context will be exterminated. Okay? I have to make sure that the server received this message. I have to get a confirmation. Once I get a confirmation, this means that both sides will close at the same time. So there is no way for the truncation attack to happen. The problem is that the standard does not dictate that explicitly, and that allowed some TLS implementations not to force this. So some TLS, because if it's not in the standard, it's up to me whether I should do it or not. صح كده؟ So some implementations of TLS did not enforce the reliable way of doing the security session closure. Okay? So the closure happens from one side, but the other side is still expecting some communication, so that facilitates some kind of truncation attack and impersonation to happen. Okay?
Doctor, I failed to see how this is useful to the attacker. He doesn't have any of the keys or any of the security context or anything.
Yeah, this is not to say that the truncation attack is enough.
Okay.
Yeah, this is not to say that. لا, it's one step, but you have to also perform impersonation attack. Okay. ماشي كده؟ Okay, so that's that part. All right, so with that, so now we have all the four protocols for TLS, and these four protocols. Remember, these four protocols are in the session level. In the connection or in the transport level, we have the record protocol, which is the actual implementation of the tunnel. Okay, type. So again, just to reiterate on this, what we talked about is that we have a TLS session. So if we talk from a time perspective, we have the TLS, which works in the same level like HTTP, the session level, يعني. And this session, okay, it facilitates the accumulation of conversation between the client and the server as part of a workflow. ماشي? So you are purchasing anything from any website. So there is information that gets accumulated. You know, like for example, you are buying some items, you add some items to the shopping cart and so on and so forth, right? So there is some continuation of information. However, from the transport level point of view, this session might contain multiple connections, multiple short-lived connections that might be either sequential or in some cases actually parallel. Okay? And these connections depend on how the web page is organized. You click on some links. Okay, some links will initiate مثلا some video, some text, some graphics being sent or something like this. So HTTP itself works on TCP, and it might instantiate multiple short-lived TCP connections that gets established closed. But all of these, they use the same tunnel or cipher spec. Okay? All of them will work on the same tunnel, will work within the same tunnel, which uses the same cipher spec. There is, of course, unless مثلا the alert protocol says something otherwise. If the alert protocol says that there's an issue, then we can go to the handshake protocol, instantiate another cipher spec, and then we use it using the change cipher spec. We have to go through the cycle again, right? But other than this, all these short-lived connections, okay, they use the same cipher spec. So this is how TLS works from a session perspective and from the transport layer perspective. So this is the record protocol, and this is the session level services, which include all the handshake, the alert protocol, the heartbeat, and all of this. ماشي? So that's how TLS works. To get into the SSH was initially designed not for web services. SSH was designed to facilitate remote control similar to Telnet, okay? To facilitate the remote login on a server, okay? It's not for web services. So it's designed based on lightweight approach on purpose, okay? Because again, it facilitates one user to do remote login on a server. So unlike TLS, it actually uses one long-term connection, okay? And again, of course, there is one tunnel. And as we will see, very similar to TLS, it uses cipher spec and everything, okay? But it uses one long-term connection. Unlike TLS, it uses short-lived connections, okay? Type. But still, remote login, I can do remote login to a server, right? And I can say, copy 100 files. And we can see these 100 files, they may actually be downloaded in parallel, right? But this is the same connection. How does this happen? So the way they do this for SSH is slightly different. So they use, unlike TLS, which uses short-lived connections, they use another concept called a channel. Channel is not a separate connection. Channel is just a logical stream, okay, which is transferred on the same connection. It's not a separate connection. So there are, within the same tunnel, you have multiple channels. But all of them, they are within the same connection. ماشي? So this is in a nutshell how SSH is designed, unlike TLS. Okay? So this is there are two major differences. This is one of them, and we'll talk about another feature of SSH in a later stage. But this is one major difference. Okay? It's one connection, and we have channels. Unlike multiple connections, and all of them are short-lived and stuff like that. Okay? طبعا we'll talk about the pros and cons of each of these. Okay? طيب. So this is in briefly the philosophy behind SSH. So SSH again it's a protocol for secure network connection designed to relatively be simple and inexpensive to facilitate basically the remote login. Okay? So here, the main purpose is to do remote login, which means that you want to remotely control all the resources on a server. Okay? If you have ever used Telnet, of course Telnet now is a bit obsolete. Not many people are using it now because HTTP really replaced all of this. But in the past, we used to have Telnet. Telnet is unsecure. It's not secure at all. Okay, everything is plain text. Okay, so SSH came to fix that and make the concept of tunneling, the concept of encryption and confidentiality and so on top of Telnet. Okay. So this is for remote login. SSH also provides more general client-server capability. Of course, in a later stage, they started to use SSH for secure FTP, for other services as well. Similar to TLS, but it started for a particular purpose, and then later on it was used for general purpose. Okay, it started first again to replace as the SSL in web services in particular. But in a later stage, people started to generalize the use of TLS in email clients and in other services as well. The same thing happened for SSH بالضبط. ماشي؟ طيب. Here we notice that SSH2 fixes a number of security flaws. And again, when we talk about security flaws, we don't mean the mechanism. We mean the protocol messages. Okay? So that's what this says. Okay. Type. Here in the architecture, you will see that there are similarities with TLS, but there are also some differences. Again, because of so we see that TCP is underneath, which means that TCP header is not to be encrypted, similar to TLS. So again, for transport layer services, transport layer security services, we are not touching the TCP header. Okay. So we have again the session level services, and here, unlike TLS, we had 4 different protocols in the session level, if you remember. We have the alert protocol, heartbeat protocol, handshake, and so on. Here we have only 2 services. We'll talk about these in details, okay? And here we have the transport layer protocol, which corresponds one-to-one to which part in TLS, اللي هو اسمه ايه؟ اسمه ايه؟ for TLS كان اسمه ايه؟ اللي هو the one that's used to secure the tunnel itself in the transport level. هو الامتحان بعد اسبوعين على فكرة عشان تبقوا عارفين يعني. In 2 weeks exactly from now. Okay, so this corresponds one-to-one to the record protocol in TLS. So in TLS, we have the record protocol, which is the tunnel protocol itself, which is in the transport layer level. Okay? So this corresponds one-to-one to that. So that's the one that has the tunnel service in terms of authentication, confidentiality, integrity, and optionally طبعا compression. Exactly similar to TLS. The one thing that's slightly different here is that server authentication is done as part of the transport layer service. Okay? So the server authentication is done. Why? Again, the philosophy behind that is that the server authentication معناها the server authenticates itself to the client. Okay? Which means that the client will log on. Once you log on any remote server, what is the first thing you get? Enter your user ID and password. صح? صح? Okay. So we deal with the client authentication as a service on top of the transport layer security service or this transport layer tunnel. Okay? So first the server authenticates itself to the client. Once the client or the user logs on, you see that you need to put the user ID and password. But the connection is established, the security context is established, and you just need to perform the user authentication. Okay? You just need to perform the user authentication. So that's why in the session level, the SSH user authentication protocol happens, or the SSH connection protocol اللي هي using the multiplexing of the channels. We talked about channel, and we'll talk about the how to multiplex channels, which is basically multiplexing multiple channels on the same tunnel. ماشي? So these are the two services as part of SSH. Again, SSH was meant to be very lightweight. ما فيش بقى التعقيدات بتاعت alert protocol وكذا وكذا. It's not part of the standard. Okay? And I'm not sure if that means that there is some issue with the heartbeat. يعني مثلا if a user leaves a session on a server open for a long period of time, I'm just thinking now. Will that also allow مثلا a firewall to kill that session? يعني I'm not sure. I'm not sure. But it's meant to be very lightweight. As you can see, it's a.
The client is configured to have a timeout. So after a certain period of time, the session will kill itself.
Yeah, but this is controlled by يعني the server controls that. The server controls that.
Not yours.
Huh?
Or not SSH.
Yeah, not مثلا that the firewall will kill it prematurely or something. There's no mention in the standard about this. ماشي? So for the transport layer protocol, which is the transport layer level, the server authentication occurs at the transport layer based on the server possessing a public key, public-private key. In terms of يعني it can exchange a certificate with the client to authenticate itself to the client. Okay? The server host key is used during the key exchange. The server host key. Remember, host key معناه إيه? The key of the host itself, not the application. The key of the host, of the entire host itself, may be exchanged with the client. This RFC dictates two alternative trust models. So for trust models, I'm trying to establish the trust. If I were to have one client, okay, and here on the other side, this client connects on multiple servers, server 1, server 2, server 3, and so on. Okay, this client connects on multiple servers. Okay, of course, each of these servers serves multiple clients as well, right? But here I'm talking about the model where one client wants to establish trust to multiple servers. So the question that we're trying to answer here is that how the client can trust these servers. When these servers start as part of the transport layer service, the server authenticates itself to the client by sending a certificate. And these certificates might be sent to the client. When the client receives that certificate, it actually stores this certificate in a local cache or a local database. So one approach is to say that when the client authenticates, when the client tries to connect to a server, it actually stores the certificate of the server in a local database, which means that the client will maintain a database of all the certificates of all the servers it tries to connect to. ماشي? That's one approach. The other approach here, which is to use an intermediate certificate authority. In that case, the client, okay, receives the certificate, of course, of the certificate authority, and it establishes the trust with the certificate authority, okay? And then every time it tries to connect to one of these servers, it has to go through the certificate authority. And then this certificate authority maintains all the certificates of these servers. Okay? If you remember when we talked about certificates, we talked about the graphical modeling of how you establish the trust. مش فاكرين؟ هتفتكر ما انت خلاص فاضل اسبوعين. Yeah, if you have multiple certificate authorities or multiple nodes that you are trying to establish trust with, so either you establish direct trust, which means that you receive the certificates from multiple nodes and you maintain it locally, or if you don't have the certificate locally, then you have to go through the certificate authorities that you trust. Okay, So this means that every time I need to connect with any of these servers, I need to communicate with the certificate authority. That doesn't say, or that doesn't mean that this is method 1, this is method 2. This is not to say that we either use this or this, because we can use both, in the sense that in the beginning, I need to establish trust with the server 0. So I will go through the certificate authority, right, which I trust already, right? And then through that, I will download the certificate or exchange the certificate of the server. And then once I receive it, I maintain it locally, right? When I try to connect to server 1, first I consult the local cache. Do I have the certificate for this server? If I do, then that's fine. If I don't, then I go through the certificate authority. So that's a like sort of mix of both approaches. واضح ولا أنا بتكلم؟ واضح؟ ليه الناس النهارده مش حاسس كده مفيش يعني الأجازة عملت يعني في idle stage حصل connection closure الفاير وول عمل premature connection closure حصل time out. So these are the two methods for establishing the trust between the client and multiple servers. Okay, and of course, the standard talks about these two methods or a mix of these two methods at the same time. Right, so this is the transport layer protocol packet exchange. Remember here, we're talking about the transport layer message exchange, okay, not the service. Okay, so you will see, for example, here the last message is from so the client is sending a message service request to the server, okay, to start authenticating itself to the server, which means that now I'm logging in, so I get by some user ID and password to type, okay, which means that I will start the client authentication with the server. ماشي؟ طيب, before that, again we'll divide it into phases. There is that phase of establishing TCP connection. This is a phase of establishing TCP connection. Okay? If you remember again from network 1, how do you establish TCP connection? Again, the client has to initiate the connection establishment. So it sends a message called a send, and then the server sends send and ACK, okay, and then the client will send ACK, and then the connection gets established. Okay, nostalgia, memory of network 1. Okay, so that's how you establish the TCP connection. And as we said, why we highlight this here? Because it's actually one connection, once and for all. Because it's here, unlike TLS, here the connection is long term. It's actually one connection. We do it once and for all. Right? In a later stage, if we want to have multiple files or multiple streams, we use the concept of channels, not connections. But this connection will stay on all the time. But in TLS, you have to do this phase for every single connection. That's why it was not included in the handshake protocol. If you go back, it was not highlighted because it has to be done every time. But here it's done once and for all. ماشي? But similar, very similar. This is actually, other than this, I think you see lots of similarities. The only difference is that you don't see here in the picture anything that talks about client authentication. مفيش. And in fact, here, حتى server authentication is hidden. It's here. Okay? The client authentication is not here. Why? Because the client authentication is part of the service. It's one of the services in the session level, not in the transport level. ماشي? Other than this, you will see lots of similarities. Here, this is exactly similar to the hello message. So here we say SSH, protocol version, software version. This is, in fact, it looks like this. So here, you have the protocol version اللي هو ال SSH مثلا 1. So you say SSH 1. And then the software version. Software is like use PuTTY. You know the client PuTTY, okay? So you say PuTTY 1.4, something like that. So that's exactly how it looks like. Okay? And the server says the same. Okay? Remember, all these strings will have to be used later on to generate, again, a big hash, which is similar to the random sequence. But here what they do is that they use accumulation of these messages to generate the hash. Unlike in TLS, they use the random sequence. The client sends the random sequence and the server sends the random. Here, it's not sent, but it's actually generated implicitly. Anyway, مش مشكلة دي. When the server sends back the same message, then we start the algorithm negotiation. Exactly similar to the hello message there. The client sends its own capabilities, again, for key exchange, for authentication, for MAC or for integrity, and for compression. All these 4 levels. For each one, I send set of mechanisms that I have capability to use. In the order of preference. Same thing. ماشي? So the client is sending, like, the client is proposing set of mechanisms with the order of preference, and then the server would say, okay, for key exchange, I'm going to use Diffie-Hellman. For authentication, I'm going to use certificate. For MAC, I'm going to use SHA-1 or HMAC or something like this, and so on. And compression, either no compression, of course, compression is optional. So either we use no compression or we use certain compression technique. Okay? So here we have an agreement, and then we start the key exchange. What's hidden here is that here, as part of here, we do also the server authentication. Because server authentication happens as part of the transport layer. Okay? So the server, again, sends the certificate, and we do the key exchange. So similarly, so here we have 2 things. We have the hash. So the slight difference here is that the hash is actually an accumulation of all the messages that have been sent before. But in TLS, we use the nonce or the random sequence. But here, we generate a hash of all these messages. The net result is the same. So here we have the hash and we have the pre-master key. Okay? Okay? Then what we do, there is no client authentication here at all. Client authentication did not happen. Server authentication only. And that's a slight difference with TLS. ماشي? Then خلاص, this is change self-respect. This corresponds exactly to change self-respect. Because here we have the pre-master key and we have the hash. We generate the keys, right? And then this is exactly similar to change self-respect. Okay? Which means that these keys will become current and we'll start using them. The main difference here is that this TCP connection is one long-term, right? Client authentication did not happen as part of the transport layer service, transport layer protocol. It happens as part of the session service. We'll talk about it. Type the hash that was generated together with the key. So this is the pre-master key and the hash. Okay. In addition to other things, we don't have to worry about them. So using the key and the hash, we generate all the 6 keys. Exactly similar to TLS. Nothing different here. ماشي? The only slight difference is there we use random sequence, here we use hash. واضح؟ ماشي كده؟ Again, this is the sequence of the protocol. So here we have the packet length and we have the padding length. صح؟ we have the padding length. Padding length is the length of the padding, which is variable. Why do we need to do padding? Huh?
For traffic analysis.
So to confuse the traffic analysis. Okay? And of course, compression is optional. And as we said before, of course, compression has to be done at the beginning. However, encryption and MAC, we use one before the other, doesn't matter. The sequence itself doesn't matter. And I did not come across anything that says consistently we have to do encryption before MAC or MAC before encryption. We can do it either way. There's no distinction. Okay? So here what we do is that we do the encryption first, and then the MAC happens after that. Meshi, that's how it's done. Meshi? So exactly similar to TLS. So this is all the possible mechanisms that can be used. The green ones here are the minimum requirements for any client or server implementation to comply with the standard, to comply with the SSH standard. Meshi? So these green ones are the minimum. Okay? So the client may in fact send to the server as part of the negotiation at the beginning, it may actually send all this list with in terms of in order of its preference. And then the server might select or negotiate any of these mechanisms on each of the pillars that we talked about. For compression, of course, the standards does not dictate any compression, which means that you may not have any compression halts. Compression is totally optional. ماشي? So for authentication here, we have three types of authentication. That for user authentication, ماشي? So because server authentication is already done, خلاص. Server authentication we talked about it, but here we're talking about client authentication. It can use these three types, or the standard actually highlights three types of authentication to the client. Either it uses public key in the sense of certificate, and here the client sends a message to the server that contains the client's public key, which means certificate, يعني. Sends a certificate to the server with the message signed by the client's private key. ماشي? When the server receives this message, it checks whether the supplied key is acceptable and so on, and using طبعا the public key of the client to authenticate the client. Okay, so that's one method, straightforward. Or the client may use the password, which means that user ID and password. And here, the client sends a message containing a plain text. Plain text, plain text. Can we send plain text? Yes, we send. Why?
Because we've already established the connection.
Bravo عليك. Yes, because already خلاص, the tunnel has been established. So plain text sent inside the tunnel, it's خلاص. It's already encrypted. Everything is encrypted. خلاص. ماشي? So when you type your password, okay, that doesn't mean it will go in plain text. It actually goes through the tunnel, and everything inside the tunnel is already encrypted. So ما فيش خوف يعني. ماشي؟ طيب, or host based. Here, public key here, this is the public key of what? Of the application. بمعنى ان client مثلا may use actually POTI. Okay? You are using POTI to establish SSH, right? So there is a public key for the application itself, and there is a public key for the host, the client host itself, which means that any application inside the host can actually use that. Okay? Which means here it's actually the public key is part of Windows. ماشي? So this is host based, which means the authentication is performed on the client's host rather than the client application. So it's not the POTI application that performs the authentication. It's the entire host. يعني the host itself has SSH built in the operating system, and the whole host authenticates itself using SSH to the server. ماشي؟ واضح كده؟ It's not يعني for a particular application. It's exactly similar to the fact that TLS can be used embedded in the web browser, or it can be used as part of the operating system. We talked about this, صح ولا لا؟ ماشي؟ Same thing. ماشي؟ So rather than directly verifying the user's identity, the SSH server verifies the identity of the client host, not the client application. ماشي؟ Any question here? Any confusion? Type. Here we'll talk about the concept of the channels. So the SSH connection protocol, which is, so now we cover the transport layer protocol, okay? We cover user authentication when we talked about user authentication being one of the services, and we talked about the 3 types of authentication for the client, whether using the client's public key for the application, or the password, which means the user ID and password, or the client host authenticates itself to the server using the host public key. ماشي? Here we're talking about the connection protocol, which is another service on top of the transport service. This connection protocol is used to multiplex the channels, the different channels, on the same connection. ماشي? So we have one connection, one long-lived connection, and of course, which is through a tunnel, using some cipherspecs, and it's totally hidden, and you have multiple channels on top of that. ماشي? ماشي. So the secure authentication connection referred to as a tunnel, is used by the connection protocol to multiplex a number of logical channels. So what is the difference between multiple connections and multiple channels? So multiple channels, the channel refers to logical stream, okay, that gets transferred over the same connection, okay. Type. Let's talk about the differences now. When it comes to multiple, these are multiple connections, okay, whether it's parallel or sequential, okay, and this works on the same, or works within the same time, or we have one very long term connection on SSH, and to provide multiple transmissions, we actually use multiplexed channels. Okay, what is the difference between these two? There are some differences, some slight differences. One thing is that connection means socket, right? Which means that for each of these connections, we have sockets at the client and the server. We have sockets, right? Buffers. Okay? And each connection has a connection context, right? So maintaining multiple connections has some kind of overhead at the transport level. So for each connection, you have to maintain sockets, separate sockets. For channels, no, you don't have to do that. Okay? So in terms of overhead, managing connections has more overhead, and that's one of the approaches for designing SSH, because it's designed to be lightweight. Yeah, it wants to be lightweight. Okay, so that serves a purpose. So the concept of multiplex channels makes SSH more light compared to TLS, right? But there is an implication of this. There is an implication for this, which we will talk about. So there is the channel mechanism. So all types of communication using SSH are supported using separate channels. So that typically happens when you log on to a remote server and you say, get 100 files. Okay, so I want to download from the server 100 files. Okay, so each of these files will get downloaded through separate session, but all of them, they use the same connection. For each channel, each side associates a unique channel number. So here we have channel number. Unlike the socket, when we talk about sockets, TCP socket is identified by what? By IP address client, IP address server, port client, port server. يعني there is some يعني overhead. Okay? But we'll talk about the disadvantage of this. So no data may be sent to a channel until a message is received to indicate that the window space is available. So this is part of يعني برضو just the fact that we have a channel that works on the same connection. برضو the connection has some advantage in terms of providing مثلا flow control. Okay, error control, things like that. Okay, so here, this is done across all the channels at the same time. But again, at least we need to identify each channel. So we have channel number. So we have channel number to identify each channel or distinguish channels from each other. So the life of a channel progresses through 3 stages. So we can open a channel, transfer data, close channel, open channel, open channel, transfer data, close channel. So again, the typical scenario for this is when you download 100 files. So you can establish all these channels in parallel and open, and once the file download finishes, the channel closes and so on. Okay? So remember this because we will talk about the implication of this in a second. So this is how the channel mechanism is working. So we already established the authentication, the transport level, and the client authentication itself is done as part of the service. SSH client authentication service is done. Okay. So here for the connection, we can now open channel and channel confirmation, and then we have to communicate, and then at the end we close channel. So it's very easy. So this is done. This sequence is done for each single channel across the or on top of the same connection, same long term connection. Okay, so it's very, very simple. ما فيهاش حاجة. These are the channel types. So each of these channels can have a certain type. So there are multiple types of these channels. So a channel might be a session, which means that the remote execution of a program. So a channel, there is one channel for controlling the remote server, which means that a channel there which I use to send the commands, put, get, things like that. All these commands are sent on one channel, okay, which is the main command session that goes through one channel, okay? There is the X11, which refers to the X window, or once I authenticate myself, مثلا, and I put the user ID and password, I can in fact activate a graphical channel or a graphical user interface, which sometimes happens when you log on to Ubuntu, مثلا. So you can have a graphical user interface. So that X11 might have like a graphical user interface which facilitates some kind of interaction between the client and the server in a graphical way, and that uses a graphical user interface. Imagine. So X allow the applications to run on a network server, but to be displayed on a desktop machine. So all the graphical content will have to be transferred in a channel, in a specific channel, which is in that case a graphical channel. And there is the port forwarding. So a channel might have a type of port forwarding, and this port forwarding can be local port forwarding or remote port forwarding. Okay? So let's talk about that after the break, because that requires a little. Okay. In order to understand and appreciate the feature of port forwarding, let's just talk about some common scenarios, which has nothing to do with security for now, and see how the port forwarding can solve these particular scenarios. So a very common scenario that, imagine, like if there is like a website, it's called restricted website. Restricted www. Okay, this site is restricted in the sense that it has some restrictions, or it has some confidential data. It has anything that there is like a firewall here, like أريد مثلا firewall. You're trying to access some website outside, and this website, whenever this website is actually detected by the firewall, it actually restricts any connection to that website. So, and remember, this website is HTTP. It's for some reason it doesn't use HTTPS, مثلا. This was very common in the past. Okay, so that's one scenario. So the client here wants to connect to that restricted website. Okay, but the website itself has HTTP, not HTTPS, which means that it does not implement TLS or SSL or SSH or something like this. So port forwarding comes handy here, because what happens is that let's talk about another scenario. Forget about security for now. Let's talk about another scenario. Another particular scenario is that you have a local machine inside your home network or any private network, okay? And this machine, okay, has a particular IP address, which could be 192.168. What is this? This is a private IP, okay? Private IP. It's not a public IP, okay? And somehow you want to make this network a server, which means it's by default isolated, because it has either a private IP, or there is again some firewall implemented on the router that also kind of blocks the access to this machine somehow. Or the machine, which is more common, the machine has a private IP address which is not exposed. So this means that this server is hidden from being exposed to the public internet. So in that case, you want to have clients to be able to access this machine as if it has a public IP, although it has a private IP. Okay, that's another typical usage, okay, where port forwarding becomes very handy, okay? So port forwarding tries to provide the feature of proxy, where you try to have a tunnel, okay, where you control the beginning and the end of this tunnel, and you can map the end of this tunnel to a particular service on the other side. So for example, if I say at the client, if I say http restrictedwebsite.com, it will get blocked by the firewall, right? And remember, the website does not have HTTPS, okay? So a very nice alternative is to have an SSH client here at the beginning of the tunnel and an SSH server at the end of the tunnel, okay? Somehow, we can establish these client and server SSH, okay? Some people, they actually try to get control on a server, let's say مثلا in the US, and they try to set up some SSH server on these machines, just to be able to bypass any kind of restrictions in the middle. Okay. Setting up the SSH client is very easy. Okay. It's just the fact that you have to have an SSH server on the other side. This is very key. Okay. After the firewall, this is very key. If you can do that, then what you could do is that you can say, you can implement port forwarding by saying, okay, so I will give you a port number, okay, at the SSH level, not the TCP port number. It's different. So in case my port forwarding. If you see this port number at the end of the tunnel, remember, this port number is encrypted because it's part of SSH. Okay? Because the TCP port is not touched. It's part of the header, and the header is not encrypted. Okay? So I give you a port number at the SSH level. If it goes inside the tunnel, everything is encrypted. Okay? If you see this port at the end of the tunnel, then map this port to restrictedwebsite.com. Okay? So this way I can bypass any kind of restrictions in the middle. But the key here is how to set up this port mapping, okay, at the beginning and the end of the tunnel. And the key here is that you have to have an SSH server on the other side, behind the firewall. If you can do that, then it's doable. Many people, they use this to get around any kind of security restrictions, which is blocked by one faculty member here. He used this trick to try to bypass all the restrictions by ITS. You just set up SSH server at some place, okay, and connect it to this SSH server, and he used the port forwarding to connect to any website he wants, which is because sometimes, to be honest, these restrictions are illogical in some cases. Some very legitimate websites and servers are totally blocked for no reason, and you don't know why. Good luck about trying to convince them that indeed this is it took me sometimes days to try to convince them to put it in the whitelist. This is a dirty solution that some people use to bypass this kind of restrictions.
VPN is easier.
VPN, of course, but remember, what is the problem with VPN? It's very expensive. Very expensive because it's a network level. So it's done on one host or group of hosts. So overhead, very high overhead. Of course, this is much faster. This one works on the level of a host, which means all the applications are going to use the VPN tunnel, right? Not just one application. But here, this is done on one application for a certain application, okay? Because the mapping has to be one-to-one. So I'm mapping this port to this particular service. And this service, it doesn't have to be, by the way, HTTP خالص. Could be FTP, could be anything. Okay, but it's just one service. Okay? This one, same thing. If I can set up SSH here and SSH here, okay, I can say, okay, so if you receive, I can set up like SSH server here and say, if you receive this kind of port at the end of the tunnel, not at the beginning, but at the end of the tunnel, okay, map this to this particular server. I might have to configure here. I have to configure on the, yes. But here the difference is this port is at the end of the tunnel. This port is at the beginning of the tunnel. And that's the difference between local port forwarding and remote port forwarding. So for this type of scenarios, we usually use the concept of local port forwarding. Here we use remote port forwarding, which means that whether the port at the beginning of the tunnel or the port at the end of the tunnel. We have local port and we have remote port, صح? In TCP, we have local port and we have remote port. So we can map the local port to a particular service, or we can have the remote port to be mapped to a particular hidden server. So these are the two scenarios where we use local port forwarding or remote port forwarding. That's in a nutshell how it works. Remember, these ports are part of SSH, which is different from TCP ports. Okay, which means that ports from SSH level are hidden, encrypted. Nobody sees them. Okay, so the only way you can see them is at the beginning of the tunnel or the end of the tunnel. Okay, so using SSH client and server, we can easily map these ports to a particular service at the end of the tunnel. واضح كده؟ So that's in a nutshell how it works. This particular, again, feature does not exist in TLS. That's one major difference as well in SSH, which was not implemented in TLS. Okay? That's why it's one of the most useful features. Many people actually use that feature. In the past it used to be very common. But now, خلاص, all the websites are by default HTTPS. Nobody uses HTTP anymore. Very few websites. But again, this can be mapped to anything, not just HTTP. It can be FTP, it can be anything. Okay? Provides the ability to convert any insecure TCP. Any insecure TCP. Okay? Connection into a secure SSH connection, also referred as SSH tunnel. Incoming TCP traffic is delivered to the appropriate application based on this mapping. So either we map the port at the beginning of the tunnel to a particular service, or the port at the end of the tunnel to a particular service. Okay? So that's how it works. So this is the insecure way. This is the TCP, plain TCP, no security at all. The problem is that here we may have like some firewall, or we may have some NAT, lower network address translation, okay, which kind of blocks the communication to happen on this side or on this side. Either a website here that might be restricted, or a server here which might be blocked or not exposed to the internet because of the fact that it has a private IP address. Okay? So here the tunnel, together with port forwarding, and this port is at the SSH level. It's very key, because this port is not seen inside the tunnel. So anything in the middle cannot see that port. Okay? So I can easily then say, okay, at the end of the tunnel, if you see that port number, map it to this service which is totally restricted, which otherwise I cannot use, I cannot access. Okay? Underneath this level, so this is the SSH level, which is, again, it's a session level. Underneath, this is TCP, and TCP is insecure, and that's the connection. But because of the fact that this tunnel is secure and everything inside it is encrypted, I can implement that feature. So there are two types, as we said. There is local port forwarding and remote port forwarding. Local port forwarding says, if you see the local port at the end of the tunnel, if you see this local port, then map it to a particular HTTP or FTP service. Okay? So this is how it's done. At the local machine, or at the local IP address, this is the local port. That's why it's called local port forwarding, or local forwarding. Okay? If you see this port, by the way, inside the tunnel will be hidden. Okay? But if you see this local port at the end of the tunnel, and this is the SSH server. Okay? So you're trying to establish that port forwarding from the client to the server, right? So in that server, you are establishing an SSH session. Okay? So if that local port is seen at the end of the tunnel at the server level, the server will map this port 80 to restricted example.com port 80, which is HTTP, not HTTPS. Okay? So this way I can get by. I can access a restricted website on HTTP without having to be blocked by any firewall, because it's encrypted. ماشي كده؟ The other
HTTPS, why can't I use this mechanism for HTTPS?
ما بقول لك هو السيرفر itself does not have the capability of HTTPS. This restricted website does not have the capability of HTTPS. If it does, then خلاص, it's fine. No, خلاص. If it's done, it's fine. خلاص. I don't have to do it. The remote port forwarding is very commonly used. Actually, يعني it became handy for me in many cases. يعني really, يعني you have a machine inside your house that somehow you want to make it a server. How can you do that? Because all the machines at home in our houses, they have private IP address, and this private IP address is not exposed to the outside world by any means. Okay, so that's the way. So in that case, you say that if you see this port as a remote port, as a remote port معناه إيه? As a destination port, not the local port. Okay. If you see this as the remote port, then map this to my local host, اللي هو بقى إيه? The hidden server inside my network. Okay. Or this could be 192.168.0.100, something like that. So I can map this. I can establish this SSH from my router at home. Okay, with any SSH server outside. So this way I can route any traffic that comes in. I can route it to any machine locally inside my house as if it's a server, although it's inside a private network. Okay? ماشي كده؟ So that's the difference between the local port forwarding and remote port forwarding as part of SSH. So that's pretty much it. So we talked about the transport layer security. We talked about the TLS architecture, the TLS protocol portfolio, including the alert, the heartbeat, the record protocol, and so on. And we talked about the handshake protocol. And then we talked about SSL, okay, which is part of which is part of the web security. And then we talked about SSH and the differences between SSH being an inexpensive or a lightweight security protocol and TLS, which uses multiple short-lived connections as part of web services. Okay. So that's